Hi students, welcome to my class. Now I am going to discuss the best problems in continuity. Okay, I already posted a video on the continuity, how to do continuity problems in three ways. I explained the three ways that was there in the three solutions, three ways of solutions. Okay, you watch that video and let us start the class, the continuity problems. Okay, now the first question is f of x is equal to 5 when x less than or equal to 1 and a plus bx when 1 less than or equal to x less than 3 and b plus 5x when 3 less than or equal to x less than 5. Don't think it is very easy question. I am not going to teach easy questions at all. Okay, just the typical questions, somewhere some confusing questions. 30 where x greater than or equal to 5. By looking this problem, everybody says that it is very easy question. Why you are discussing the typical model questions? It's a typical one. You see the answer and then you say whether it is correct or wrong. Okay, then it is so this question is given, find the values of a and b. The options are different. Everybody think that it is oh, it's very just easy, but you see the answer. Okay, now suppose it is continuous. I am going to, in the question itself they didn't give that it is continuous. Okay, let us suppose if it is continuous is not given, then f is, the question is f of x is like this, then f is only. They didn't give it is continuous, find the values of a and b. 4 different options are given. Okay, now let us see. Suppose if I am assuming that it is continuous, so 1 plus is equal to 1 minus. What about 1 plus value? 1 plus value means we have to consider this function a plus bx. So when x is equal to 1, because I am going to write 1 plus, so a plus b. So what about 1 minus value? 1 minus value is 5, so a plus b is equal to 5. So we have a relation. Now let us take 3 plus. 3 plus means we have to write this function 5b plus 5 into x. X means I am going to take 3. So b plus 15. b plus 5 into 3. 3 minus is equal to a plus b into 3. So we have one more relation, that is a minus 2b. Am I right? So a minus 2b is equal to 15. So we have one equation, this is another equation. By solving these two, a cancel. You don't think that the answer is correct. Don't think otherwise. It is a typical question. I will explain why it is. It's a different question. So a cancel. So we have minus b is equal to 20. So b is equal to minus 20. Am I right? Now it is a plus 2b. Sorry, it is a plus 2b. A plus 2b only. So a plus 2b is equal to 15, and we have this one. By subtracting you will get minus b is equal to minus 10, b is equal to 10. If b is equal to 10, what about a? That is minus 5. A is equal to minus 5. Am I right? So exactly it's correct. Now you don't think that the answer is this one. Now you see 5 plus and 5 minus, what happens? 5 plus. 5 plus means answer is 30 and 5 minus is b plus 5 into 5, that is 25. B is equal to 5. We observe what about the value of b? If it is continuous, the answer is 5. B is equal to 5. What we got here? B is equal to 10. So this function may not be continuous. So it is a previous question that was given. So here the b value is 5. If it is continuous everywhere, the values of a and b should be equal. So, but here we are getting b value is equal to 5, but here we are getting b value is equal to 10. Okay. Now the answer is nothing but this function is discontinuous. Okay. That is the difference of this question. Now, because we are getting different values of a and b, so that's why we can say it is discontinuous. Now let us see the next question. Modulus of f of x minus f of y is less than or equal to 2 of x minus y whole to the power of 3 by 2 and f of 0 is equal to 1, then integral 1 to 2 f square of x is equal to what? You see the question. So this is the question, and f of 0 is equal to 1. What we have to find? Integral 1 to 2 f square of x dx is equal to. You see, limit as x tends to y. I am going to take x tends to y. Why I am going to take this one, I will explain. Modulus of f of x minus f of y by, this is nothing but 2 into x minus y into root of x minus y. We can write like this, 2 into x minus y. This is a into a power, a into root a power 3 by 2, just like this. So x minus y is less than or equal to, so when it comes to this side, we have remaining is 2 into root of x minus y only. Am I right? Okay. So let us see, I am going to take x minus y as h. X minus y is equal to h. Then what happens for the value of x is equal to y plus h? Am I right? X is equal to y plus h. Now limit as x tends to y means we can write x minus y tends to 0. Now x minus y means h tends to 0. That is f of x means y plus h minus f of y by h. By looking this one, I think you have some memory. That is nothing but f dash of y. Okay, am I right? F dash of x is equal to, you have to remember from the first principle, limit as h tends to 0, f of x plus h minus f of x by h. That is the definition of differentiation. F dash x is equal to this one. So this is nothing but f dash of y. So this is nothing but f dash of y. Okay, f dash of y is less than or equal to 2 into root of, we have to apply limit also here, x tends to y. X tends to y means you replace x with y, y minus y 0. So 2 into 0, 0. So here this value becomes 0. So f dash y less than or equal to 0. F dash y means the constant derivative of some function is less than or equal to 0. Less than or equal to 0 means that is just nothing but a constant only. Okay, so it is just a constant. So we can say that f of x is a constant function. We can say that f of x is a constant because f dash y, what is meant by f dash y? Differentiation of function is less than 0. 0 means it's a value. So less than 0 means just nothing but a value. Whenever differentiation value becomes a constant, that means the function should be a constant function. So f of x is a constant function. But you see the question, f of 0 is equal to 1 is given. So f of x is constant means whatever might be the value here, that goes to 1 only, because f of 0, 0, 1, 2, 3, whatever the value you can take, that value goes to 1 only. So what about the function f of x? You can write that is nothing but 1, because given f of 0 is equal to 1 only. Now the function f of x is equal to 1. So what about f square of 1? That is also 1. So integral 2 to 1, 1 to 2, 1 dx. 1 means x, 1 to 2. Again the answer is 1. Okay, so it is also one of the different question. Okay, let us move to the next question. So all questions will be different questions, and previous questions, you see that we watch the complete video, then we have some idea how to do the JEE level problems. Okay, let us move the next question, that is f of x is equal to, this is it's a very beautiful question, minimum of sin x comma cos x, minimum of sin x comma cos x in the interval minus pi to pi, open interval, it is not differentiable at. So whenever you are going to do the continuity topic, we have to do differentiability also, because both these two are like to be, we can say the twins, continuity and differentiability, the twins topic, I can say. Now f of x is minimum of sin x comma cos x. You should be patient by listening these type of questions, because these type of questions are very important for JEE levels. Now you see, these are two curves. One is sin x and other one is cos x. I am going to draw the graph of sin x and cos x. You see, this is minus pi and minus pi by 2. In between them we have minus 3 pi by 4 and minus pi by 4. it is 0, pi by 4, and it is pi by 2, 3 pi by 4, and it is pi. Okay. Now see the graph of first sin x. Everybody knows that graph of sin x is like this, and it is like this. This is the graph of sin x. What about the graph of cos x? That is 1, and it is 0, and it is minus 1. So it will be like this, and it is like this. Okay. So the three curves intersect at the points. These are the points. Okay. This is the graph of sin x and cos x, but not the graph of minimum of this one. Now I am going to take the graph of minimum of sin x comma cos x. You see minimum, which function is minimum in between minus pi to pi? You see this graph, cos x graph is minimum up to here. Am I right? I am going to draw the graph of minimum graph here. Here the values are minus pi, minus 3 pi by 4, and minus pi by 2, minus pi by 4, 0, pi by 4, pi by 2, 3 pi by 4, and again it is pi. You see, up to 3 pi by 4 cos x is minimum. So the graph will be like this. Now sin x graph will be the minimum up to here only, because cos x graph is upper curve when compared with sin x in between minus 3 pi by 4 to pi by 4. You see, am I right? Now the graph of this one is like this. So this is the graph of cos x. Okay, up to pi by 4. Up to pi by 4. Sin x, this is the sin x is minimum. So after pi by 4, you see sin x will be the more than that of cos x. So cos x will be the minimum graph. So cos x will be the minimum graph. So this is the graph. You see, this is the graph. And at these 2 points, you see, these 2 points will be the point of intersections. Whenever point of intersections are there for any two curves, at that point the curves will be changed their direction. That is called sharp edge. Suddenly it takes changes its direction. Then we can call it a sharp edge. You see the graph of cos x coming like this, and it moves as sin x. So it will be the sharp edge, because this is the point of intersection. These two are point of intersection. Suddenly at these 2 points, the graph of minimum of sin x and cos x changes its directions. Not this point. This is a single curve like this. It will be same like this. It will be moving like this. But suddenly here is the point where the cos x graph, sin x graph suddenly moves as sin x, because the graph will be changes minimum. We have to draw the minimum graph. So cos x, sin x graph will be moves like this, and cos x graph will be like this. So here the point where sin x will be the greater value that of cos x. Okay. Now these 2 points, the graph is continuous. You see, there is no any restriction point. The graph will be continuously like this. This is the graph. The graph moves like this. This is the graph. There is no breaking point at all. It moves continuously. There is no break at all. So, but these 2 points are called sharp edges. At these 2 points, the graph is takes sharp edge. At those 2 points, the function is not differentiable. What about the points? Minus 3 by 4, and this point is pi by 4. At these 2 points, f of x is not differentiable. And but the function is continuous. The graph will be continuous. Okay. Next, move to the next question. How the problem is? Next, move to the next question. That is 4th question, I think so. Let k be the set of all real numbers where the function f of x is equal to sin of mod x minus mod x. All the problems are different problems. Don't skip away any problem. Just you see all the questions and watch the complete video till the end of this class. Let k be the set of all real numbers is not differentiable, then k. It is not differentiable, then we have to find the values of where the function is not differentiable. In options 0 is there. Is differentiable, continuous and differentiable at x is equal to 0. Point is at x is equal to 0 is given. Okay, so we have to verify the options. That is, now what happens here? 2 into x minus pi, that's enough. Now let us take 0 plus, limit as x tends to 0 plus. Already told you number of times, mod x means it is a plus x or minus x, it depends on the value of x. Now you see, x tends to 0 plus. 0 plus means sin x will be positive, plus x, and this is also positive, minus x, plus 2x minus 2 pi. So then what about the function? Sin x minus x plus 2x, that is x minus 2 pi. While substituting 0, 0 minus 2 pi, so we have minus 2 pi. This is f of x, okay? This is f of x and this is f of 0. Then what about the f dash x here? We just find f dash x, cos x sin x derivative cos x derivative 1 minus 0. Then f dash of 0 is equal to 1 plus 1, that is equal to 2. Okay? Now 0 minus, what about the function f of x? 0 minus, just less than 0. Less than 0 means mod x is negative. Okay? Sin of minus x, that is minus sin x. Mod x is also negative, minus x. Minus of minus, plus x, and it is 2x minus 2 pi. Now, what will be the function? F of x is equal to minus sin x plus 3x minus 2 pi. Then what about f of 0? You substitute 0 here, 0 plus 0 minus 2 pi. Minus 2 pi, you see here is also minus 2 pi, here is also minus 2 pi, that we can say that the function is continuous. Okay, the function is continuous because at 0 plus and 0 minus we are getting the both values, that means the function is continuous at x is equal to 0. Then what about the differentiation? Now I am going to discuss about differentiability. At now this is f of x, then what about f dash x? That is minus cos x and plus 3 and 0. Now f dash of 0, that is cos 0, that is minus 1. So 0, it is minus 1. So minus 1, cos 0 is 1, minus 1 plus 3, that is again 2. So we are getting the same value at f dash of 0 also. So which indicates that this function is differentiable and continuous. Of course it is continuous and also differentiable. First you have to say continuous. If it is the continuous, may be differentiable, may not be differentiable, but it is differentiable also, because after differentiating and substituting value of x, we are getting the same value. So this function is continuous and differentiable at x is equal to 0. Okay, let us move to the next question. Next question. Next one, that is what about that question? F of x is equal to, next fifth question, f of x is equal to minus 1 and x square minus 1, where minus 2 is less than or equal to x less than 0, 0 less than or equal to x less than or equal to 2, and g of x is equal to, you see this how the different question it is, modulus of f of x plus f of mod x, f of mod x. Then in the interval, open interval minus 2 to 2, g of x is, what about g of x is? Okay, in options it's differentiable at x is equal to 1, not differentiable at x is equal to 1, like that. So we have to verify whether g of x is differentiable at x is equal to 1 or not. First you verify the continuity. Okay, you see g of x is modulus of f of x. In between minus 2 to 2, you see the function, the limits of this question, g of x is in between minus 2 to 2. Okay, let us take minus 2 to 0, g of x. What about g of x? Minus 2 to 0, the function is minus 1. This is minus 1. So modulus of minus 1 plus f of mod x, here is minus 1 only. So we have to write minus 1. 1 minus 1, that becomes 0. Okay? So that will be same. 0. This answer, remember this question, the answer, that is 0. Then what happens in between 0 to 2? In between 0 to 2. So we have only minus 2 to 0, the function is minus 1, Modulus of minus 1 plus f of modulus means that is also minus 1. So 1 minus 1 becomes 0 only. Okay. Now you see 0 to 2 what happens? 0 to 2. So g of x is equal to modulus of f of x means x square minus 1 plus f of mod x, that means we have to write mod x square minus 1. Is it clear? Now this is the question. Now we have mod x is there and modulus of x square minus 1. So we have to take two cases. One is in between 0 to 1 and another case 1 to 2. So you take in between 0 to 1. In between 0 to 1 you take any value and square that value minus 1, you will get negative value. So minus of x square minus 1. So in between 0 to 1 that mod x is plus only. So x square minus 1. So minus x square plus x square cancel. 1 minus 1, it should be 0. Okay. So what about the function? Function will be 0. F of x is equal to 0 only. Minus x square plus x square. It's cancel minus 1 plus 1. Function is 0. Okay. Now what about f dash x? It is also 0. Now in between 1 to 2. You take any value in between 1 to 2. Suppose 1.1, 1.2. 1.1 square minus 1. You will get a positive value. So I am going to write this one as x square minus 1. And this is also plus x square minus 1. So you will get 2x square minus 2. When x is equal to, I am going to take it 1. Okay. Now that is 2 into 1 minus 2. That is also 0. So here is 0 and here is 0. That means the function is continuous. Okay. And here is also in between minus 2 to 0. I already told you that answer is, you have to remember the answer is 0. So the entire value is 0. That means g of x is continuous at x is equal to 0. Then what about differentiability? Okay. So here the differentiation becomes 0 and this is the function f of x when 1 is less than x less than 2. Then what about f dash x? F dash x is equal to 4x only. 4x minus 0. But we are going to find it 1. Suppose the value is 1, you will get 4. Okay. Here f dash x is equal to 0 means f dash of 1 0, f dash of 1 also 0. But here f dash of 1 is equal to 4. It is not differentiable because these two values are not equal. So we can say g of x is not differentiable at x is equal to 1. Okay. But it is continuous. Continuous and not differentiable. Okay. Let us move to the next question. So each question takes some time to explain, but while doing yourself, it will take below 1 minute. Nothing to worry because I am going to explain mod x problem and everything, all the cases. It takes some time, but whenever you are going to do these type of problems, it will be complete within 1 minute or 1.5 minutes. Nothing to worry. Okay. Next, going to take one more, the best question. This is the one of the best question. F of x is equal to, you see, maximum of mod x comma x square and 8 minus 2 mod x, where here mod x less than or equal to 2 and 2 mod x less than or equal to 4. In minus 4 to 4, f is not differentiable yet. In the interval minus 4 to 4, f is not differentiable at the point. F is not differentiable. Of course, we have to verify that it is continuous or also. So, this is one of the best questions. It takes some time. If you have command and graphs, then you can do very simple. Maximum of these two graphs. I will draw the graphs. This is mod x graph will be like this. And what about the x square graph? X square graph will be like this. Okay. So, maximum, you see, the maximum is graph x square up to here only. Now mod x graph will be the maximum from here to here. Now graph x square will be the maximum. Okay, is it clear? Now the graph of maximum is, so this is the maximum graph. Okay, so we have to draw like this, the curve, and this is line, and this is line, and this is the graph. This is maximum of these two. Okay. Now let us draw this graph. 8 minus 2 mod x. It's very easy. Nothing to worry. You take mod x as plus one time and you take minus one time. So you will get 8 minus 2x and 8 plus 2x. Suppose mod x is equal to minus x, then it becomes 8 plus 2x. So always take this is y and this is also y. Okay. So the first equation will be 2x plus y is equal to 8. That is x by 4 plus y by 8 is equal to 1. A straight line. Okay. This is the straight line. Okay. Where the two curves meet. This is the curve x square and this is the curve 8 minus 2x. 8 minus 2x. So x square plus 2x minus 8 is equal to 0. That is x plus 4 into x minus 2 is equal to 0. So x is equal to 2. So both the curves meet at 2. Okay. Is it clear? Of course, the same curve, another line y is equal to 8 plus 2x, the line will be like this. It meets this curve x square at x is equal to minus 2. Okay. Now, this is the graph of these two curves. Okay. Now, you see this is the graph. One line coming like this and this will be the point minus 2 and this is the point minus 1 and this is 0. And this one is 1 and this one is 2. So now you can say there will be sharp edge like this, the graph coming like this and here will be the curve and again it is a straight line and again it moves the complete direction, it changes, suddenly it takes a sharp edge, this is called sharp edge and now it takes curve and here it is one more sharp edge. So you see 1 point, 2, 3, 4 and 5. What about the points? This is minus 2, minus 1, 0, 1 and it is 2. At these 5 points, the graph, the curve f of x is not differentiable. Of course, it is continuous. Okay, you see the graph will be continuous like this. Whatever now the shapes it occurs, but the graph will be continuous we can draw. We can't lift the pen from the board. Okay, so that's why we can say that it is continuous but not differentiable at these 5 points. The graph is not differentiable. Okay. Now, so while doing the continuity and differentiability, you should be patient because sometimes you can lose your temper. How the problem comes. Next question. This is also a good question. F maps from minus 1 to 1 tends to R and f of x is equal to maximum of minus mod x and minus root of 1 minus x square and f is not differentiable continuous. Same model question. Whenever maximum or minimum such type of questions will be there, the options will be same like continuous but not differentiable, discontinuous, not differentiable. Such type of options will be there. You see maximum of minus mod x. Actually mod x means the graph will be like this, but it is minus mod x. Now the graph will be like this. This is minus mod x graph. Okay. Now what about the graph of this one? You see, I will explain you. Let us take that is equal to y. Y is equal to this one. So y square is equal to 1 minus x square. X square plus y square is equal to 1. It is a circle. Then why? How to draw? You don't draw the graph like this. So this is the upper part. Upper part means positive part of y, and this will be the negative part of y. So suppose the question is y is equal to root of 1 minus x square. You have to draw the graph like this. Since because it is y is equal to root of 1 minus root of, you have to draw the graph. The graph will be like this. Okay, it is a semicircle. Okay, is it clear? Now maximum. So what about the maximum? So maximum is a negative side. Negative side means whenever the values increases, the value will be less. So minus 5, minus 5. So this is the less values, and here the values are increasing. That's why the value will be less. So this is the maximum, and this will be the maximum. Okay. Now what about the graph of that one? It is a curve, and then sharp edge like this, and this is a curve. Okay. So these are the sharp edges, but the graph is continuously, it is moving in between the given interval. Okay, so now we can say it is continuous but not differentiable. These are the points where it is not differentiable. So when we have to say, whenever you say the points, just you find out the points. Okay, you equate these two, then you will get these 2 points, and this is nothing but 0. So number of points will be 3. Okay, next question. Next one. F of x is equal to, next 8th question, f of x is equal to a into modulus of pi minus x plus 1, b into modulus of x minus pi plus 3, and where x less than or equal to 5 and x greater than 5 is continuous at x is equal to 5, is continuous at x is equal to 5, then what about the value of a minus b? Now you see, I am telling the easiest and shortest way to find these type of solutions. You see, continuous means the value of 5 plus is equal to 5 minus. Now you take 5 plus, what happens? 5 plus means we have to take this function. 5 plus means 5.1. So 5.1 minus 3.4, you will get a positive value. Now I am going to write like this. X minus x plus low, I am going to write in x I am going to write 5 minus pi plus 3 is equal to 5 minus, what about 5 minus value? This is the function 5 minus. 5 minus means just you take 4.9. 5 minus means just less than 5. So 3.14 minus 4.9, you will get negative. Okay, negative means minus a of pi minus x. X means 5 plus 1. Now you see b of 5 minus 5, and when it comes to the side, plus a of pi minus 5 is equal to 1 minus 3. Now you can take 5 minus 5 common, or pi minus 5, whatever it is. So it is 5. So minus a, and here is plus b is equal to minus 2. Okay, now we can write here pi minus 5 of a minus b, taking minus as common, and here is minus common, so that is minus 2. Now a minus b is equal to minus 2 by 5 minus 5, or 2 by 5 minus pi. Okay, so that will be the answer for that question. Now I am going to explain one more the best question. And it is 8th or 9th question. So f of x is equal to step x minus step of x by 4 at x is equal to 4. It is continuous or discontinuous? It's very simple question, I think so. 4 plus, what happens? 4 plus means whenever step is there, that is just a value. So 4 plus means 4.1, it means 4 minus 4.1 by 4, it is 1 point something. Now step is 1, now it is 3. 4 minus means 3.9. Step of 3.9 means 3. 3.9 by 4 means 0 point something. Step of 0 point something is 0. That is equal to 3. Now exactly 4, what happens? That is 4 minus 4 by 4, 1. That is also 3. So these 3 values are equal. At 4 plus 4 minus, these 3 values are equal. Now we can say the function is continuous at x is equal to 4. Okay. Now let us move to the next question. Wow, it is one of the best question, I think so. Next question is very important, and it's just like advanced level question. It's a 10th question. F of x is equal to 15 minus modulus of x minus 10, and g of x is equal to f of x, not differentiable at the points. How many points are there and what are they? Now you see g of x, we have to find g of x where it is not differentiable. So g of x means f of x. What is f of x? 15 minus modulus of x minus 10. So f of this one is equal to 15 minus modulus of, in x you replace this value, 15 minus modulus of x minus 10 minus 10. Okay, this is f of x. Okay, now what happens here? That is 15 minus modulus of 15 minus 10, 5 minus modulus of x minus 10. You see, one modulus is at x is equal to 10, x 10, and one modulus is 5 minus. So we have to check the functions. So we have to take first one, x minus 10. You take this modulus of x minus 10. So when it is x greater than 10, what happens? And x less than 10, what happens? Okay, suppose x greater than 10. X greater than 10 means 15 minus, x greater than 10 means 10 minus 10 plus x greater than 10 minus 10, we get a positive value. So 15 minus modulus of 5 minus of x minus 10, that is 15 minus modulus of, this is again we are getting 15 minus x, right? 5 minus of minus 10, 15 minus x, and if x less than 10, you will get modulus of 5 minus, it will be minus when x less than 10, minus of minus plus x minus 10. So we have 15 minus modulus of x minus 5. Okay. So again we have to consider two more cases here and two more cases here also. One is I am going here x greater than 10. You remember in your mind that is x greater than 10, but it is 15 modulus of 15 minus x. So it is in between 10 to 15. It is because it is greater than 10, in between 10 to 15 and greater than 15. Okay. Now what about in between 10 is less than x less than 15? Then what happens? 10 less than x less than 15. So if 10 less than x less than 15 means the value in between 10 to 15, that is less than 15. 15 minus less than 15 value, it will be positive. So 15 minus x. So it will be cancelled and we have x only. Okay. Now x greater than 15, we have 15 minus, greater than 15 means you will get negative. Always here is also negative. So 15 minus x, that is 30 minus x. Okay. Now you see here we have to consider two cases also. Modulus of x minus 5 means x greater than 5, x less than 5. But it is x less than 10 I am going to take. Here is x less than 10, but that is 5 to 10 and less than 5. So 5 to 10, any value, so it is 15 minus of x minus 5, that is 20 minus x. When x less than 5 it is negative, 15 negative plus of x minus 5, that is 10 plus x. So we have the entire problem comes to end with 4 functions. Okay. Now I am going to write the 4 functions here. The complete problem reduces into 4 functions, that is f of x is equal to, so now I can define the function as f of x is equal to, what about the function when it is less than 5, what about that function? 10 plus x, x less than 5. In between 5 to 10, what about the function? That is 20 minus x. Now 10 to 15, that is 10 less than x less than 15, that is x. And what about the fourth one? That is x greater than 15, that is 30 minus x. So function. Okay. Now the function defines like this. Now you can draw the graph, or you can find 5 plus and 5 minus, 10 plus 10 minus, you can do like that. Okay. So what about the graph? It is 5 or 10 and 15. These are enough. X less than 5, the graph will be 10 plus x. 10 plus x means y is equal to x plus 10, that is x minus y is equal to minus 10, x by 10, y by x negative, y positive. X negative, y positive means x negative, y positive, like this. And this is 5 to 10. X minus 10, y is equal to 10, x minus 10, y 10. The graph will be like this. Okay. Up to 5 only, this one. X negative minus 10, y is 10 positive. So the graph will be like this. Up to 5 only. 5 to 10 you have to draw the graph. Y is equal to 20 minus x. X plus y is equal to 20. Okay. X by 20 and y by 20. The graph will be like this. From this is 5 to 10 only. The graph will be like this only. 10. At 10 to 15, we have to draw this graph, that is y is equal to x. Y is equal to x is a straight line which is passing through origin like this. Okay. Now, and from greater than 15, that is y is equal to 30 minus x. X plus y is equal to 30. So x by 30, y by 30, the line will be like this. Okay. Now this is the graph. You see here we are getting sharp edges. That means it is not differentiable at the points. What about the points 5, 10 and 15? At these 3 points the function is not differentiable, but the graph is continuous. It is continuous. Okay. So let us move to the next question. Okay. Next, I think 11th or 12th. F maps R to R be differentiable at C belongs to R, and f of C is equal to 0. F of C is equal to 0. And if g of x is equal to modulus of f of x, then at x is equal to C, the answer is g of x is differentiable at if f of x, f dash x is equal to 0. This is the answer we have to prove. Okay. Let us see this question. This is also one of the good question. G of x is equal to like this, but we have to choose from the among the options. G of x is differentiable. Whenever a function is differentiable, we can write like g dash x is equal to limit as h tends to 0 g of x plus h minus g of x by h. Am I right? This is the definition of differentiation from the first principle. Now what about g of x plus h? G of x is equal to this one. Now it is modulus of x plus h minus g of x means mod of x plus h by h. But the question we have to find at C. Now we replace h with C. Then what happens here? That is C tends to 0, and replace wherever h, you write just C. Okay. But in the question, f of C, this is also C. This is, sorry, just a moment. This is nothing but limit as h tends to 0. What is this one? Modulus of x plus h minus modulus of f of x by h. Is it okay? Clear? Now we are going to find x is equal to c. X is equal to c. Don't replace h. Just replace x with c. F of c plus h minus f of c by h. But f of c is equal to 0, so this becomes 0. Now we have limit as h tends to 0, f of c plus h modulus of by h. Okay, is it clear? Now it is modulus. Modulus means we have to consider either positive or negative. And that means two cases. One case is limit as h tends to 0, f of c plus h by h, and limit as h tends to 0, f of minus f of c plus h by h. How to find this differentiation? Just by using L'Hospital rule. If h tends to 0, denominator 0, we can apply L'Hospital rule. That is f dash of c plus h by 1. But as h tends to 0, it becomes f dash of c because h tends to 0. Now here is also minus f dash of c plus h by 1. So when h tends to 0, that is minus f dash of c. So we have what we have. G dash x is equal to, we have two values, f dash c, and one more value is minus f dash c. Okay. So the given question is g of x is a differentiable. If it is differentiable, these two values must be equal. So whenever a positive value and negative value equal, that means that value nothing but 0. So if it is 0, and this will be also equal to 0. So if f dash c is equal to 0, then these two values must be 0, then g dash x exists. Otherwise, you will get two different values, then the function is not differentiable. So if g of x should be differentiable, then f dash c is equal to 0. Now the answer is g of x is differentiable whenever f dash c is equal to 0 only. Okay? Okay. The next one. Now the next question is 12th question. You see that question is f of x is equal to root 2 cos x minus 1 by cot x minus 1 is equal to k, x not equal to pi by 4, x is equal to pi by 4 is a continuous, then k is equal to, it's a simple question. So we have to find limit as x tends to pi by 4, root 2 cos x minus 1 by cot x minus 1. I already explained in a previous video that such type of questions will be given. You find the limit at this point as x tends to pi by 4, and this should be equal to this value. Okay, so take L'Hospital because denominator 0, that is minus root 2 sin x by minus cosecant square x, minus cancel. As x tends to pi by 4, this is becomes root 2 of 1 by root 2 by 2. Now the answer is 1 by 2. Okay, is it clear? Now going to the next, it's an easy question, and I will explain the different question now. 13th question. F maps from minus 1 to 3 tends to R, and f of x is defined at 3 cases: mod x plus step x, and x plus mod x, and x plus step x. That is 2 less than or equal to x less than or equal to 3, 1 less than or equal to x less than 2, and minus 1 less than or equal to less than 1 only. Okay, so f is discontinuous at the points, So whenever step x is there, we have to take the x values as 1 unit gap only, but it is given minus 1 to 1. So I am going to take minus 1 to 0. What happens? Minus 1 to 0, step x value is minus 1 only. Okay, so mod x is equal to minus x and step x is equal to minus 1. Okay, Now from 0 to 1 what happens? Including 0 but excluding 1, the same function is mod x is positive and step x is 0, that is x. Now from 1 to 2, what happens from 1 to 2? From 1 to 2, step x mod x is a positive value. So x plus x, we can write 2x. From 2 to 3, we can write step x is equal to 2 to 3, not including 3, just excluding 3, x plus 2. That is x plus 2 only. So we have 4 lines. These are the 4 lines. This is, let it be y, y, y and y. Just by using the graph, you see, from -1, 0, 1, 2, 3. Now you see, from -1 to 0 we have to draw this diagram. Y is equal to minus x minus 1. That means x plus y is equal to 1. So the line will be like this. But don't touch the line, try to touch this line y axis, because at x is equal to 0, we have y is equal to x, this line. Okay? So 0 to 1, this is the line, and from 1 to 2, that is 2x. Not don't combine these two lines. This is y is equal to x and this is y is equal to 2x from 1 to 2. 2 to 3, we have one more line, x plus 2. Then maybe the line will be like this. Y is equal to x plus 2 means x minus y is equal to minus x negative, y positive, minus 2 plus 2. So the line may be like this. Okay? So this is will be line. This is the line. So you see, at this point it is discontinuous, at this point it is discontinuous, at this point it is discontinuous. So we have 1, 2, 3. This is 0. Don't take that point. 1, 2, 3. So 3 points of discontinuity. And what about the points? At 0, 1, 2. Okay. So this is about the question. Now I am going to explain one more different question. Of course, these problems are somewhat difficult in my opinion, but if you have practice in continuity and discontinuity, then it will be very easy for you. And now this is limits question, and yes, this is also limits question. Limits. Yes, I told this question. Next question, that is 14th question. F of x is equal to sine of p plus 1 of x plus sine x whole divided by x when x less than 0 and is q, and root of x plus x square minus root x by x to the power of 3 by 2 when x greater than 0. This is x is equal x is equal to 0. So we have this one is continuous, then the values of p and q is continuous. So continuous, then the value of p and q. Okay, continuous means these three values are equal. 0 less than value is equal to 0 value. What about 0 minus? 0 minus means this is question, limit as x tends to 0 minus. So if we substitute 0, we will get not defined. So we can apply L'Hospital. What about the derivative of this one? P plus 1 of cos of p plus 1 x plus sin x derivative cos x, and by x means x derivative 1. Okay. Now you apply 0, that is cos 0 1. So we have p plus 1 and this is cos 0 1. So it is p plus 2 is equal to, that value q is equal to 0 plus. 0 plus means we have to find the limit for this question. 0 plus. How to do this problem? You see, the denominator is x power 3 by 2. That is nothing but x into root x. Now in the numerator I am going to take x as common. So you will get root x into root of, here root x is common. So it comes to outside, that is root x. So 1 plus x minus root x by x into root x. So root x cancel. So we have root of 1 plus x minus 1 by x. Limit as x tends to 0 plus. Now if you substitute 0, you will get not defined value. Then you can apply L'Hospital rule. that is 1 by 2 root 1 plus x. X means 0, so that is 1 by 2. So this is all equal to 1 by 2. So this entire value is equal to 1 by 2. So we have p plus 2 is equal to q is equal to 1 by 2. That means q is equal to 1 by 2 and p plus 2 is equal to 1 by 2. So p is equal to 1 by 2 minus 2 minus 3 by 2. So p is equal to minus 3 by 2 and q is equal to, that is minus 3 by 2. Let us go to the next question. Best questions. Differentiability, I will explain that question also. So we have one more question. I will conclude this class with this problem. Maximum I tried to explain different questions. Now the 15th question, that is f is continuous, f maps R to R is continuous and differentiable, and f of 2 is equal to 6 and f dash of 2 is equal to 1 by 48, and integral 6 to f of x 4t cube dt is equal to x minus 2 of g of x. Then limit as x tends to 2, g of x is equal to. So limit as x tends to 2, g of x means g of 2. We have to find g of 2. What is g of x? You see, g of x is equal to integral 6 to f of x 4t cube dt by x minus 2. Now limit as x tends to 2. Here is also limit as x tends to 2. When x tends to 2, it will be 0. So we can apply L'Hospital rule by using Leibniz theorem. The derivative of integration, I think you know very well. So f dash x into, substitute here f of x whole cube minus 6th derivative is 0 by x derivative 1, 2 derivative 0. As x tends to 2. As x tends to 2, it becomes f dash 2 into 4 of f of 2 whole cube. Okay. So what about f dash 2? That is 1 by 48. 4 into f of 2 means 6. 6 cube, 6 into 6, 6 into 4, 24, 2 times, it is 3 times. Now the answer is 18. So these are the few important questions that was given in previous JEE. So let us practice yourself and do the best problems as you can. If you have any doubts, you post your doubts in the comments box, and share your friends this video. And thanks for watching my video, and try to say your friends subscribe to my channel. Okay, right, thank you.